When we are measuring energy changes, there are different units that we can use. A calorie is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. So when you see calories on food, that's really an energy unit. The calories on food, though, are actually kilocalories. There are 1,000 of these calories here. The SI unit of energy, the one that we really use most often, is joule. 1 calorie is equivalent to 4.184 joules. When you are calculating the amount of energy, aka heat, needed to change the temperature of a substance, there are 3 things that are going to determine how much energy is needed. The amount of the substance being heated in grams. 1 gram of something is easier to heat up than 100 grams of it. How big is that temperature change? It's easier to change 1 degree than 1,000 degrees. And then lastly, the identity of the substance. Some substances just change temperature much more easily than others. If you think about heating up a pot of water on the stove, you put the pot of water on the stove, you turn the stove on, the pot gets hot much, much, much faster than the water. It's much easier to heat up metal than it is to heat up water. And this is because of a concept called specific heat. So specific heat, symbol is S, is the amount of energy needed to change the temperature of 1 gram of a substance, any substance, by 1 degree Celsius. So this is the same as the definition of calorie, except calorie is specific to water. Specific heat is any substance. So the specific heat of water is 1 calorie. We do measure it in this class, however, in a unit that's a combined unit, joules per gram degree Celsius. So joules over grams times degree Celsius. The higher the specific heat, the more energy it takes to change the temperature. So something like water with a specific heat of 4.184 joules per gram degree Celsius takes much more energy than something like gold, which is 0.13. Iron is 0.45 joules per gram degree Celsius. So it takes 0.45 joules to change 1 gram of iron 1 degree Celsius. It takes 10 times as much energy to change water. It takes 4.184 joules to change 1 gram of water 1 degree Celsius. So the higher the specific heat, the more energy required to change the temperature. This brings us to our next formula in this chapter. Energy, heat, Q, equals specific heat times mass times change in temperature. So Q equals SM delta T. Change in temperature is always your final temperature minus your initial temperature. So you can have a negative change in temperature. It's not the big number minus the small number. It's the final number minus the initial number. If I put something in the refrigerator, the temperature is going to go down, so I would have a negative delta T. So we will determine the amount of energy in joules required to raise the temperature of 7.4 grams of water from 29 to 46. So I got an M, I got a T. I'm determining amount of energy, that's Q. So I know I'm using Q equals SM delta T. The specific heat of water is 4.184 joules per gram degree Celsius. That's from that table on the other side. I didn't do any magic to get that number. It's a standard value. Okay, so that will always be S for water. So I don't know my Q. My specific heat's 4.184 joules per gram degree Celsius. My mass is 7.4 grams, and then my temperature change is my final temperature, 46, minus my initial temperature, 29. And so that is a temperature change of negative 17. Nope, not negative. Sorry, that's a temperature change of 17 degrees Celsius. So we just plug in 4.184 joules per gram degree Celsius times 7.4 grams times 17 degrees Celsius. Degrees Celsius and grams cancel with the unit of S. So my answer comes out to 526, and the unit is joules because that's the unit left uncanceled in my specific heat. 3 sig figs because all of my given information was 3 sig figs. This one, the specific heat of iron is 0.45 joules per gram degree Celsius. So again, that's just a standard value. So I have an S, I have a mass, I have 2 temperatures, so there's going to be a temperature change, and I'm again determining the quantity of energy, which is Q. We're just going to do this one in joules. We're not going to worry about converting to calories. So same thing, Sm delta T, Q is my unknown. In this case, because it's a different substance, there's a different specific heat. So iron's 0.45, the mass is 1.3, and then the temperature change is 46 minus 25, which is 21. So plug that in. Times 1.3 grams times 21 degrees Celsius. And I'm going to get 12 joules, which is actually a really small amount of energy. So both these examples, we were solving for Q. Of course, it is entirely possible I could give you a Q and you're solving for M, or give you a Q and you're solving for S. Just like we've been doing, use that guess method, look at what you're given, look at what your unknown is, write your variables down, and then solve for the unknown.